Alright, yeah, stream is up. Let me just go in here and do that. Is up. Okay, looks to be good audio. Good audio. Let me just put this in. Let me split these messages. Oh my god. Okay, let's go from here. Alright, there we go. And I'll post the link inside of the Discord. Alright, we should be good. Just one more second to check everything, make sure everything is set up. Got Obsidian, Paint, the right project. I think I have everything set up properly. Yeah. What's up, Jennifer? Welcome to the stream. And yeah, I guess we can start. What's up, Exo? Guess we can start. I need to remember where I left off yesterday. Yeah, we finished the parse expression, right? What's the agenda for today? I mean, I guess just finishing up these last two functions so we can make this work. Error handling probably for the consume function. We gotta set up an actual error thing. For error handling, we have to set up a couple things. I don't know much about error handling, so I didn't look into error handling too much, so we might need some help there. But we have Cloud, so that's fine. But hopefully we can figure it out. So yeah, not function, let function, error handling we have to do, and then probably just setting up the parse code function. So that seems like a good plan. Alright then, let's just kind of start. Let me just go through, let me reread this parse expression to see exactly what I remember. So, advancing this first token, returning this, advancing to this, and then we set that token within the node function to actually call that to work. So set it as a literal node, and as long as the remaining part, as long as the binding power of the next character is greater than the minimum binding power, then we keep moving. So this advance consumes this token, moves on to, I don't know, Y or something, and then we set up the left node for the operator and X, and so on, as long as the expression keeps going. So however long they do with any expression, it'll keep looping. We'll keep calling this function over and over again until it resolves everything. But yeah, that works. So now we need to set up the individual functions to actually make it recognize that this is a singular token that's just for a literal token, nothing to its left. And then this will take in an operator and a value to its left. Okay. Let's kind of think about it. I believe I put in my notes a couple of use cases of these certain functions. Hopefully audio is okay. I did check the audio earlier, but yeah, it should be good. Alright, so a couple of use cases of node function. null denotation. So let me see. Oh yeah, here. Start of expressions, like we acknowledge start of expressions, like just starting with x. We don't have anything to its left. So I'm just gonna write that here so we can handle each edge case as we need. So start of expressions. Yeah, like numbers, identifiers, or unary, okay. So numbers, identifiers, unary. And I don't know if other edge cases, if I didn't write it in here, but I guess we can check with Claude after to see if I covered everything. Okay, let's see. So we're trying to define what this singular individual token would be. It can be anything. It doesn't have to be this X, so it can be like one, I don't know, anything that they put. So we need to think. So I mean, I guess we can probably say that literals are defined a bit differently than stuff like unary. Unary is probably going to be more so. Unary, we have something like not x or minus y. So for unary, we have to do the operator and the next one. But for start of expressions, numbers, identifiers, we're just taking, I guess, for numbers, we're taking the literal value. Numbers would just be, let me see in here. We do have a unary op node to actually take that from when we do that part. And for numbers, it's just literal nodes. Numbers or any type of value. For identifiers, we have identifier nodes specifically. Oh, does function call count as one of our things? I mean, I guess function call would be more of a... I'll see. It might be more of a LED thing, LED thing, lefty notation. I need to see though. But I believe that, yeah, numbers we'll just call like a literal node here, and then we'll probably say for like... what was the other one? Identifiers, yeah, sorry. Identifiers. Oh, I need an extra one. Identifiers. We'll probably just be calling a identifier node. Okay. I mean, I guess we have to distinguish between them. So we might make like a switch case statement here. So possibly taking the token type that we have that we passed into nud. So we'll probably say like switch token.type. And we want the cases to be the individual tokens, and we can kind of group them in. So let's handle the easier ones first. Let's just do literals. Literals are going to be falling in, I mean, under these strings, numbers. I mean, I guess identifiers are also, but we distinguish them. So strings and numbers like that. So I mean, I guess the case would just be the number, right? So I guess we could probably say token type of a number or string, anything like that. So number, probably numbers, strings, anything else that really falls under that. And should we count strings in this case? Because it is a literal, but it's not really like... I mean, yeah, we have to count them, I guess. So we can probably say, yeah, case token type number, maybe fall through that and say case token type string. And I believe that's it. We'll do identifiers with a different case, so we'll probably say with this, what exactly are we returning here? We're returning a unique pointer here, so return, so we already have the unique pointer in our abstract syntax tree. Yeah, we should have that in there already, so we can probably say return std make unique, but it's going to be for the literal node. For the literal node, and we want to make that value the I mean, I guess the token dot literal value. So token dot literal. Yo, what's up, Ghost? Yeah, I've been using comments just to map out everything. I guess it's kind of just a thing that helps me out. I don't know if it's you or someone else. When I was writing the lecture, someone recommended I write more comments to document my code. It might have been you though, Jennifer. I just don't remember. I just remember someone did tell me to write comments more, document. I'll probably go back to the lecture and write comments throughout everything. Yeah, that was you, yeah. Alright. This just makes it easier for me as well to kind of map their things out. Okay, so token.literal for the literal value. That's the first case. We want to have, I'll write a comment here too. Let's say, oh, you're leaving, Ghost? See you, bro. Good night. Literal values. I don't know like the extent of what comments to put though, because code should mostly be self-documenting, but I guess it's fine to have these. And we can say for the next one, we want to handle identifiers, so we'll call this identifiers. And we'll say case token type identifier. And for the case of this, it's just one, so we don't need another fall through. And we'll say returns the make unique identifier node, I believe. Identifier node. And this would be token dot what? Literal value, I guess? Well, let me go back in here. Let me see. So the type, like the word of it, the lexeme, this is like the value of the literal. It'll be a monostate for this. For a literal, I believe, right? Because there's not really a value, so it'll probably be still monostate. Maybe, I'm not sure. Yeah, line number, that's not, we don't need that in here, but I mean, I guess just the token itself, right? let me see in the AST. Token name. Just the name. Okay, so it's just the token itself, it's not the literal, so we can just say token. And yeah, that's good for that. Unary case. Unary case. Alright. Case, and there's two unary cases that I'm aware of. It's not X or the prefix minus, the minus part of the prefix. So for the case of token type, exclamation, and I guess also case token type minus. Alright, then these two will return everything. So we'll say return, or this is different. This is different. We can't just return a value. We need to, how do we handle the minus and the I said the wrong thing, but the not and the minus. Because we'll be returning two values here. Yeah, we would be returning two values, but wait, how do I... Well, let me look at the unary. The unary takes the operator and also the operand. So, because it's taking these two values, we can return these two values. Yeah, so we'll wanna, okay, so we'll wanna return did make unique. Can't type did make unique unary up node. And we want to say potentially like token. Why not have like a space in between each? We'll say, okay, so it's operator and operand. So I guess oh, how do we grab the operand or the operator? Because we know the operand will just be the token dot. I mean, just token. I guess just token. But how do we grab the operand? Gonna be right back for about 15 minutes. Alright, that's all cool. Leave my stream open, I appreciate that. See you in 15 minutes. Okay, wait. Let me see. How do we get the operand here? Well, I guess the operand would, I mean, we'd probably just call the parse expression, right? So they'd probably say like auto op and set that as maybe like just the parse expression, right? So in this case, it will call parse expression, and that should handle that here. Which in this case, it would grab. Let me do this case here. It would do this. This is our first token, and then in the while loop, our node here. So we're gonna say, well, wait, huh? That's kind of weird. Well, we want our value here to bind to this. So we should probably, okay. We don't want this to even go through. So we're gonna say our binding power is gonna be 100 as the minimum binding power, something high. Because I remember let me go to our binding power table. Our max is 60, let's just say 100. Let's just say like 100 or something. And set that gap. So we'll say, where is it? Yeah, here. We'll say, parse expression, we'll say 100 here. So that'll say the minimum binding power. So it will just bind to this unary operator, and then we can probably set token yeah. Well, it's gonna be a pointer, right? So what we have to do is to move. Okay, that should be good. So, is that it? I think that's it. I might ask Claude for the edge case here. See if I covered everything. Covered every case I need. Yeah, so I'll probably go to Claude and say, have I covered every edge case here? I think this should be it, but maybe I'm missing something. So I'm gonna see if there's any other edge cases here. Let me give him my Lexer tokens. Edge case here for the nud function. I mean, I think it should be it for the nud function based off my tokens. Let's see, two important cases. Grouped expressions with parentheses. I see. And the default case, okay, yeah, the default case, I didn't know grouped expressions actually fall into this. Okay, that shouldn't be too hard. Let me just map it out real quick. Let's call this grouped expressions. And grouped expressions will be something like 1 plus 2 times 3. So I didn't know nud actually handled this, but I guess it does. Why does nud handle this? Let me think about it. I guess it's hard to know if this is binding or not. I don't know. Well, I guess, okay. In our binding power table, right? The start of a parentheses, left parentheses is a binding power of 60. It is 60, so that's the highest binding power of anything. It's even higher. Actually, wait. We also had unary, but I guess the reason we didn't use that there was because minus is not unary. But here we get, I guess we can just call left parentheses as the binding power, right? So for a grouped expression, it starts with the left parentheses, and we want everything inside of this to be binded as 1. We don't want it to do the multiplication. So I guess we can say case if the token type is left parentheses. But I guess everything inside of this expression should just be handled normally, because it could be potentially like this or this. We just don't want the outside to be able to access and be computed, so everything just needs to stay in here. So it's very similar to just handing it off to the parse expression. So let me see if I can find something similar to go off of. Don't think I can though. I mean, I guess it's just like this. We just call regular parse expression 0. So we can possibly say parse expression, say 0. What's up, Bastion? You're from Justin's stream, right? Yeah, you found me from the Justin Discord server. That's really interesting, man. Nice to have you here. Currently writing a compiler. We're in the parser phase right now. I'm a little different from Justin. I'm not doing game dev, but yeah, I just like tuning into Justin's streams whenever I can. Alright, so parse expression. So this should call, after the left parentheses, it should call anything within the, it should handle this function basically. Anything within the parentheses. Any expression. So parse expression, but after we parse this expression, it's gonna give us back this expression back here, but we want to say, we want to get the closing parentheses here. You didn't know I was a YouTuber? Yeah, I don't really advertise it on there, so I'm glad you're here though. Did Justin end the stream? Because I was on it like 10 minutes ago. He was still streaming there. I guess he ended it. So, okay, so we'll probably say consume, because we need a parentheses. If this parentheses is not closed, it's gonna generate a compiler error. So let's say consume token type, and we'll say right parentheses. Did it wrong. Right parentheses. There we go. And the error message, if it does not, he ended the stream. Yeah, I thought so. And we'll say expected right parentheses after D. Do I say D usually? No, I just say after. I don't add D. Okay, we'll keep it consistent. After expression, I guess. After expression. So you just did a massive monitor upgrade. I remember you said that the monitor or something was late by 4 days. Did it arrive, or is it still in the works of being delivered? Expected. Okay, so we're gonna say, I think that's it, right? Left parentheses, anything expression, right parentheses. Is it did arrive but super late? Yeah, that's unfortunate. But at least now you have it, so you can set up the upgrade. So right parentheses, and I guess that's it. Do we want to do anything with this after though? Oh, I forgot one thing. Let's call it auto expert. Forgot one thing there. And I mean, I guess not. Let's just say return expert. Looped expressions, and I believe we also need to do the default case. Went from a 32-inch 1080p to 27-inch 4K. That's a big upgrade. That's a big upgrade. Especially if you're playing games, that's gonna really boost not so much the performance, but it's just gonna be like much smoother. Alright, for the default case, I believe Claude said something about that. one small structural issue. Your minus and exclamation case is an auto-op declaration inside a switch case without braces. In C++, declaring a variable inside a case without braces called... Oh, it does? I did not know that. I did not know that, actually. Okay. That's interesting. And we probably want that here too, since we're making an expression. What's up, Swan? Welcome back, Jennifer. Also went from VA panel to IPS. I don't know what a VA panel is. I don't know what an IPS either is. All I can think of when you say IPS is intrusion prevention system, but I don't know if that's what you're talking about. Probably not, though. I don't know what you're talking about exactly for that part. Yeah. I actually didn't know that if you're initializing anything inside a case, you need a parentheses. I did not know that. I don't know why that's the case, though. Why does it make a difference? Any other issue? Yeah. Default case. If node receives a token, it doesn't recognize a false switch, not return. Yeah. Yeah, that makes sense, yeah. Why? Let me ask a question. Why stood runtime error and not just stood there? Okay, we needed to stop okay. Yeah, we needed to stop execution. Okay. Okay. That's interesting. Okay, so use those for just warnings, but then we need these for if anything actually goes wrong, then we need to jump back. Okay. So how do we write the syntax for that? Yeah, throw. Okay, so throw an error. Okay. Throw runtime error. Okay, just finished it for me. And unexpected token and expression. Okay. Yeah, we just write the thing in here. Okay. I guess we learned something new about that. Well, two new things. We learned the case statement. If you're initializing, we need braces, and we also learned which cases we use. Did runtime error over did ser. Unexpected token. Yeah, an expression. We'll say that, yeah. Alright, we're done. We had a couple issues, but we fixed it. VA has very vibrant colors, but has slower response time and ghosting. And IPS has better color, no color shifting, and great viewing angles. Interesting, interesting. Yeah, I guess he does love his PC. Okay, that should handle the nud function. Now we need the left denotation function, the led function. Yeah, having a 4K monitor is insane, not gonna lie. That is an insane flex. Okay, alright, left denotation is gonna be a bit different. This only happens for singular characters if there's nothing to the left, but for the case of the led function, we need something that covers anything on the left and the current operator. So the left will be passed in from nud, which that we handled in here. We already handled that. We just need to figure out how to actually do this. 219 Canadian? Dang. I don't know what the conversion from Canadian is to USD, but yeah, that's interesting. What is it? I'm actually curious. That's 158 US dollars. That's actually very cheap. For a 4K monitor, that's very cheap. That's really nice. Guess the Canadians are different. Okay, let's think about lead, right? So I wrote a couple cases for the lead function. Let's just see. Middle of expressions. Yeah, so yeah, just handles those infix tokens, so. Yeah, he scammed the seller right there, dude. That's the crazy deal. Okay, so for our lead functions, this is where we handle all the other parts of our binding power table. So, I mean, I guess the only thing that really matters for this is left associativity and right associativity. Handling these specific values is done by this parse expression anyways. So we don't need to handle the values, we just need to handle two cases. One, if it's left to right associativity, and if it's right to left associativity. And the only case where it's right to left is assignment. So low key, I might just grab all these. Well, not assignment. I'll grab all of these except for assignment. Probably. Well, probably not all of these. We already covered left parentheses, so we want to cover equal equal, exclamation equal, all these down. Not exclamation either, so just these. And let's do like a case, another switch case statement. So let's say switch, and this will be the operator type. So op.type. We'll say case. Well, I'm just gonna copy and paste that, and I'm just gonna remove the values since we're just following through each one. So we can just like remove all of these. GTX 1660 Super isn't a big fan though. Yeah, you gotta upgrade that GPU. That's a very old one. But if you do, then that would be amazing. You got a 5060? That's crazy. That's crazy. Mine's a 3070. RTX 3070. That's crazy. 5060 is crazy. Okay. Getting rid of these. Let's get rid of these. Let's say... Okay, so we're covering all the comparison, equality, and anything regular here. So these are all left to right. So, let's see. How should we handle this? These are all left to right. So, I mean, I guess it's just the regular binding power, right? We want to get the binding power for each of these operations. So we'll say int BP, we'll say, and then we'll call the binding power function, and we'll say that's for the operator that we passed in. And for each type we want to call, okay, let me map. I know I map things out a lot, but let's just see. So we have A times B, or A plus B times C minus 2, or something along those lines. What CPU do you have? I think it's like Intel i7 something. I don't know the exact model. I just know it's Intel i7. I don't know which exact i7 model, but calling binding power on our operator, but we probably want to parse the expression. So we want to parse the expression. So let's say we already went through this. We are on this one now. When we call parse expression, it grabs this. It grabs this, right? It grabs this value b, and it asks. Let me go back up here. So the value b, it will be here. It's making a singular value. It's gonna go through the while loop. Well, it may or may not, but in this case it would, because our binding power for plus is less than our binding power of our next token, which would be the multiplication. So it does enter the while loop and does handle b times c, and so on, and just keep going. So we probably want to do auto, we'll call it expression, just like usual, and we'll say that's gonna call parse expression, but we're gonna set the min binding power as our plus binding power. So we're gonna say, well, not exactly op, the binding power, sorry, this is binding power we set for operator, yeah. And is that it? Will it handle everything by itself after that? Control-Shift-Tab, is that an actual thing? I see. Oh, it opens Task Manager. I just do Control-Alt-Delete and press Task Manager. I didn't know there's a command for it. Interesting. Okay, parse expression. Yeah, I think that should cover. I think I kind of have like the whole mental map down here for this. So it does not on A, then it hits the plus, which it then goes to this function, sets a binding power for this, calls expression again to handle nud for this, but then since binding power for this is more, it enters that loop, and then we do the loop all over again. Nud for this, since this binding power is less, it does group these together, and since it's left to right associativity, it should do this, and then it should do the -2. Okay, I think that works. I think that works. Hey, what's up, Light Juice? Thinking about starting to code? Nice, you should. You should, man. Yeah, probably don't start with C++, to be honest. Python, Java, I mean, I guess Java's also a good starter language. It depends on what you want, though. If you're interested in web apps, probably do like JavaScript or TypeScript. Python. C if you want to do like low-level stuff. C. And it also depends if you're trying to get a job, because there are some languages better than C for systems level stuff, like Odin, Rust, but they have less job opportunities, so depends on what you want, really. If it's just a hobby, you can start with any language, really. Oh, C#'s also good for jobs too. C# with a .NET framework. Okay, yeah, this is good. I feel like our thing looks pretty good for now. And oh yeah, we need to return. This is gonna be for the binary op node. So binary op node. Yeah, so yeah, C# handles a lot of stuff, even games, yeah. Unity development. So what exactly are we returning? So I know we have some unique pointers in here, so we're gonna just take unique for the binary operation, binary op node, and we're gonna say this returns a lot, so I'm gonna do this. The left value that we passed, so we're gonna say okay, I'm taking too long to make a decision. Just to move left. Operator's not a unique pointer, so it can just be op. And the right value too. The right value would just be our expression. Why don't we rename it to not right? We can rename it to right, so it's better. And we'll say not a unique pointer, stick move on our right. Yeah, that seems good. And that should be good. Yes, as a hobby, yeah. I know people are really loving like Odin for system programming stuff, because it's very easy to use, and also Odin's good for game development as well. Yeah, TypeScript is... I see people say TypeScript is better than JavaScript, and there's more jobs for TypeScript as well than JavaScript. Yeah, I've been looking into Odin. It was made because they wanted to make something better than C, but not as obnoxious as C++. I've been looking into that for my next language, if I just want to do it as a hobby. Because it's good for systems, it's good for game development, not so much for like web development or stuff, or app development. I looked into that and it said Odin's not the best for that. It doesn't have good support for that. I think it came out 2015 or something. It's very niche, I guess, but not too much. A lot of people use it, but it's more niche than Rust and Zig. But a lot of people say it's better than C. Like it's much easier, not better, but like much easier to write, and doesn't have like the complexities of C++. It's more of a data-driven language, not an object-oriented. It adds on to C without adding the complexities of C++ stuff. Like, doesn't have like unique pointers and all those unique pointers, OOP, and all the other weird stuff that C++ has that I haven't gotten into yet. But oh, does it not have any circular dependencies handling? That's interesting. I've just been looking into like whether I should do Rust or Zig or Odin for the next one. I know common complaints about Zig is that there's no like stable build. Some people are saying that it's still currently being developed a lot, so it's not really a stable build. Java, I know 100% about it. I use it to develop for loops, functions, and all. You only know HTML. That's interesting, Lego. Yeah, Lego, this is C++. Shit, didn't you see it? I mean, the title says writing a C compiler in C++, so I thought I was pretty clear about that part. Okay. Yeah, no, this is actually assembly code. It's not C++, it's assembly. Yeah, I don't know. I've seen complaints for each language, but I've seen the least complaints for Odin. But I'm not sure if that's actually the case. I need to research more before I actually start another one. And I'm still learning C++, so I have to make sure I don't fall off in C++ too. All right, let's continue on. Unfortunately, this is not all there is in a LED function. We also have to handle right to left associativity. So, this will be for the case of, let me actually write it as a comment. Left to right. And case token type. The only case for right to left that we have in our language so far is going to be assignment, which is going to be the equal. So, actually, wait. Yeah, I forgot. We need the thing here. I remember you needed to have, and also I put it outside of the case here. It needs to be here. And also, this is gonna go here to close that off. Alright, there we go. And we'll say this is like right to left. Sensitivity. Is that VS Code? This is a Visual Studio Community. Just a regular one, not VS Code. Okay. Alright, yeah, commenter. Probably formatted. Doesn't really matter, but I don't know, I like to just have it formatted. Okay, so case for equal. We're probably gonna be initializing something, so let me do that. And we're gonna have, for the equal one, okay, let me write it out. X equals Y. For assignment, I'm not allowing deep nesting. We already talked about that yesterday. There's not really a point. I don't think so, at least. So we'll say might get back into cheat development. Not gonna lie, C and C++ is really good for it. Yeah, I'd assume it is. I'd assume it is very good at that. I mean, a lot of games are written in C++, so I think it could fit in perfectly. You know, change your channel name. Interesting. Yeah, like C++ is interesting, like right now, but I'm only saying that because I'm not that far into it, so I haven't really gotten into the frustrating parts yet. But it's really interesting to learn so far. I think I'm enjoying it more than other languages that I've learned. Alright, so... Alright. Welcome back. I need 500 glasses. Oh, you changed your name to that? Okay, interesting. Interesting, Lego. Interesting. That's crazy. Alright, right to left assignment. So we're gonna take the... This is different because... Okay, how do we do the right to left? This one is more straightforward. This needs to... Well, no, okay. this needs to bind with this, right? Okay, wait, that's weird. It should be C++20, the version. I mean, I know for sure it's going to be the same here. We're going to grab the binding power of the operator that we have, but the right value, right? Not binding power. Parse expression of BP, but okay, so in this case, go and join my Discord server. I appreciate it. It's in the description. It's in the description of the stream, and also I put it in the beginning as well of the stream. I should probably pin the message, but yeah, I'll pin the message. This GitHub link and the project are in the description. Okay, I'm really confused about the right to left. How do I have to approach this? How do we make it so that it focuses on the right side first? And I guess binding power, it matters, so let me run through it. So when we approach this, it doesn't know yet what type of expression, so it's just gonna say nud on X, and it's gonna reach into Y, and not Y, it's gonna get to the equal sign, and our binding power for that is just gonna be, I believe it's the 10 or 5, yeah, assignment is the lowest binding power, so it's gonna be 5 there. For Y, well, okay, so parsing expression EP. I mean, is it not right to left associativity? That's what it said on. Oops. RTP. Yeah, sorry about the white screen here. Probably it's blinding your eyes. Where is it? It should be pretty low down. Assignment. It is, yeah, so assignment is right to left. That's why I'm doing right to left, so I can just follow like the actual way to do it. So but does that only matter if it's like, well, it should matter for all of them, right? This might be a question for Claude, not gonna lie. Okay, well, I know for sure, well, we can just write the rest. I know for sure it's gonna be something similar, very similar. It's gonna be the exact same thing. Don't we collect X via a ned? Yeah, we collect X via ned. Pass it on, yeah. So we collect this X here, and we pass it on this this next part with the equal sign that's passed on to the let function through parse-expr. But it was easier for this case to run through, but I don't know, this case is kind of confusing for me. This case is very simple. Like the nud function here, right? We get to plus, it has a binding power of a certain amount, like 30 or 40. Then it passes a new nud function for this one, for b, and the while loop statement for this, the binding power of multiplication is higher than the binding power of plus, so the while loop does execute, and so on, advances to this one, makes this one a nud, and then, well, no, this one a nud, groups these together, and then it should just do left to right associativity from there. ChatGPT or Claude? Claude's better. I'm actually not sure. Does it matter for this case at all? Am I just overthinking? Because I guess in this case it would matter, right? Because we want to go from right to left. But still, we're going right to left from here, though, y2x. So I don't know. I might need to ask Claude. This one's kind of a brain twister here. I don't know. Yeah, Claude's better than... I think my... Not for agentic AI, but I think for... I'm talking about regular, just like... using it like this. I'd say best is Claude, then probably Gemini, then ChatGPT. And Copilot's way down. Copilot's so bad. I caught him many times getting things wrong where it shouldn't have. But that was like a couple months ago, so it might be different now. Yeah, I'm gonna ask Claude about this. Let's give it my whole function here. Let's give it my whole function. Let's see. Yeah, Copilot's very dumb. For the case of right to left associated. For assignment, I'm not sure what exactly I need to. My language, I am not allowing nested assignment. I don't see the need for it. Unless you want to argue about that. Unless you want to advocate for it. Yeah. Yeah, I don't really want it. But yeah, it wasn't about nesting itself. Current operator's binding power. The recursive call only consumes operator that binds strictly tighter. Yeah, as we know, we covered that case. I understood that. I understood this case very well. I just don't understand the bottom case. Right associative pass BP -1. -1. Interesting. I think he meant England, but now I'm from the USA. I think he just mistyped that. Okay, wait, why BP -1? Recursive call consumes operators at the same binding power 2, pulling them into the right side. It technically doesn't matter for your case, you'll never have 2 in a row, but for correctness and future safety, assignment should still pass BP -1 to signal its right associative nature. Okay, you didn't explain why exactly, though. Or maybe I can run through it. I don't know. I mean, I guess it doesn't matter, right? For me. I mean, in this case, right? For this case, passing nud. This will have BP -1, so BP -1. Then we get to Y as a nud, and then we get this one, which is... Wouldn't it also be BP -1? So wouldn't these be the same? How would it know to do that? Because this BP isn't higher if they're both BP minus 1. Or does... wait. Yeah, it should be the UK itself, right? I said England as a... I just said England, but I meant like the whole of UK. Pass BP minus 1 since it means you bind more tightly to the right form of the same operator. It forms x equals y equals e, which forms x equals y equals e. Okay. Yeah, I'm just having a bit of trouble wrapping it around my head for this one. I don't know why. This one was so intuitive, but this one actually confuses me. But I'm not gonna question it. Well, I should be questioning it, but yeah, let's just do BP minus 1. What's up? 500. I don't know what to even call you anymore. I was just calling you Lego before, but I don't even know what to call you now. What's up? Why do you sound so surprised? I mean, that should be it then, right? What other cases are there? Just call you Lego still, alright? That's good to me. Okay. Last case should be the function call. So let's type so it's gonna be like function arg, any amount of args they pass in. So yeah, we didn't make a function call a singular expression. We had a unique pointer of a bunch of expressions. What's up, AJ Brady? Welcome to the stream. Where did that come from? That meme? Did I say it accidentally or what? Okay, so the function name for a function call node, we have the function name and the arguments. We do have the arguments. So. Arguments will be a vector of a bunch of arguments, or a bunch of expressions, I mean, to get each argument. Each argument could be an expression, so let's see. We'll say well, the way to get into it would just be the thing like that, the left parentheses. Wait a minute. Okay, that's why. Okay. Yeah, this left parentheses and this left parentheses is separated. I hope they don't collide later. Let's see, so left parentheses, that's to get into the function call. It's probably copy that over. Not here. Let's just say it's subjective args. And it will keep adding arguments until it reaches the right parentheses. So probably a while loop since we're going through each one. What's up, Fayez? Welcome to the stream. Yeah, it's crazy. I recently made risc-v 32 emulator in C++ and want to make a C compiler for it as well. Dang, we're in the same boat then. We're in the same boat. I just literally finished the compiler, not a compiler, the emulator a couple days ago. Now I'm doing a compiler for it. And a C compiler too. That's crazy. Peas in a pod right there. Yeah, I do. No, I don't have my team mods. I guess I have one mod, but yeah. I have one mod. I might give mod out later. Because I'm still new to having all these people join, so I need to build up like that rep to see who I should pass mod to. Did some C program for fun today. I dearly miss first class functions. It's nice, interesting. I think people enjoy C, but it does have some pain points for some people. With some lack of functionality there. But it's not as much as a pain point. As C++. It's not as much as a pain point as C++. If you need mod will be the best. Yeah, we'll see. We'll see. Alright, okay, so where was I at? The arguments were passing in one by one. So probably say like not if while we're, as long as our next token, or the current token, as long as our current token isn't a right parentheses. So that's gonna be for the check function, because that checks the current one. As long as we're not a token type of right, I'll just do it like this, okay, right parentheses. Any other case, not really right. I mean, no, not really. So while it's not like that, wait a minute. Okay, so each argument is separated by a comma. We need to make sure to check that as well. So could we possibly say like, okay, so we'll probably add to the, we'll say arguments underscore pushback, and we'll say for each argument that's kind of like an expression, right? So we want to just do the parse expr function. Oh, sorry, it should be like this. Yes, arguments of pushback, parse expr, and it should pass in just the main body power 0. It's just a regular expression. So, but we probably want to have a case here, right? So we want to say maybe if as soon as we push that case, okay, wait, let's say we push this first one, right? Parse expression should advance it already. Yeah, parse expression automatically advances it for me. So I don't need to worry about that. It should have already advanced the next one. But before we get to the next one, well, the next one will be R, comma. So we want to check if check token type, comma. Crafting interpreter is good for learning the basics of compilers. Doesn't work for C through C itself. They do have they have Java and C. They have running a bytecode, I think like a bytecode VM or something. At the second half of the book, the first half of the book is just a Java interpreter. They cover the front end of interpreters and compilers should be the same. So you can use crafting interpreters. Chapters 4 through 6 actually go through the front end properly. And then I'm gonna need to go through a different book for the back end of compilers, which I'll need to see. But for the front end, I did crafting interpreters, chapters 4 through 6. It was pretty helpful. I'm completely new to compilers. Yeah, it is good, yeah. I'm surprised didn't have devs, not an engineer. Not yet. Hopefully someday. Maybe next year. Ideally, I want to get like a compiler internship for my third year summer, which is the next summer. Something like that. But I wouldn't mind if I just got some generic C++ role either. That wouldn't be too bad. What's your thoughts on Go? I haven't looked into like Go that much. I hear a decent amount of complaints about it. I forgot what they complained about, but it's been a while since I looked at a video on the complaints and stuff. But a lot of people like Go, especially for like back-end frameworks, I'm pretty sure. Yeah, I don't know where I'd find one either, to be honest. A compiler internship. Like I was talking with, I think it was Gemini, I was just talking about like how do I get those opportunities, and it said like there's some like forums where they have like every start of the month they post like some job things or something, and there's some tools that automatically detect the openings for those. So I'm not sure. I need to look into that. But that's when I get to that point where I'm decent enough to actually apply. But yeah, I wouldn't mind with any low level systems role, to be honest. 10's torrent is risc-v. I've heard of. I think I've heard of them before. Yeah, it's not easier than Python, but I didn't enjoy it. Python's fine. I didn't enjoy it that much coding it. I'd mostly vibe code for Python, so it was kind of boring. Okay, let's continue. Okay, if we're checking the comma, if it's a comma, we should move on. Well, okay. This is what we'll do. If it's not a comma, it's invalid, right? It should be invalid, so in that case, I guess a break, or not a break. I mean, yeah, I guess a break, but also we want to, I might be doing this completely wrong, but a break, but also say maybe, I don't know. I'll come back to this part, but okay. That's the first part, but after this part, we need to do, we need to get the right parentheses. So that should be after all of this. So after we've done all our arguments in the while loop, we want to check if we need to have the right parentheses for sure. If not, we need to say expected right parentheses after args. Yes, that's good. I haven't been putting periods consistently. Okay, yeah, we're good. So let's run through it, right? So if we have something like function arguments, as long as our check is in the right parentheses, we will push back first expression, which will advance it to this. It will check if it's a comma or not, and then break if it is. We also want to do our normal return. This should be for function call mode, so. Now you should learn the Java part. Yeah, you should learn the Java part. I mean, it's pretty much, it's quite different, but you can understand the general concepts, so you can start applying it. All you really need to know is the basic, a good understanding of the front end, of how it works, how the Lexer works, and how the parser works. And I'd recommend you probably write some notes. I have you can probably use my notes too. Go to my GitHub. My notes for the parser and the Lexer are on there. This is what I basically use to map everything out, get a good understanding. GitHub link is in the description. You can go to my page. It should be in there, Obsidian, somewhere in my repo, one of the repos. So you can use that to follow along. But yeah, don't skip the Java part. Okay, returns to make unique, and we'll say func. This should be for func call node. We'll say function call node just returns 2 values, right? It should be the function name and arguments. So the name will just be okay, wait, let me go back in here. So you need pointer function name, so that should be, okay, we'll call skip move. On what exactly though? Like the left value, the left node, but what is it though for this? I know for sure it's ours for the vector part, but I guess, okay, yeah, just yeah, the left value that they passed through, that they gave us there. It shouldn't be colon there. It should be semicolon here. think you need to scope case statements. Yeah, sorry about that. Yeah, I totally forgot. I just learned that later. I just learned that earlier today about if you have an initialization in here, you just scope it. Should be, yeah, right here. Yeah, I appreciate you reminding me. But yeah. And also welcome to the stream. Wellzard. Compiler made of redstone in Minecraft. Someone probably did that. What's up, No Gung? Welcome to the stream. Yeah, I think that's good. We need a default case too. Yo, I appreciate it, Wellzard. Appreciate the support. We'll probably say, yeah, we need to do the default case. The default case, and that'll be, I'll just copy it from here. Unexpected token from expression. Yeah, what's up, No Gun? Go ahead, ask me anything. Depends on what you want. I mean, Python usually just people use that to learn programs, so they're very similar in simplicity. Lua is also very good. It's a very simple language, Lua. Yeah, I realize that's one. And also, like, earlier Claude said that we need to have it for initialization. Any initialization statements, we need to have the scope for that. But yeah, I think we're good. Well, this is for operators, so let me just maybe... Well, token's fine. Token's fine, that's fine. Maybe to be more specific, I might say operator, though. Unexpected operator expression. I want to check this. I'm really not sure if I did this right. Just want to learn something for fun. Yeah, you can go with either Python or Lua. Python and Lua are very, like, similar, to be honest. So, they map pretty well. Their syntax is very similar. I just want to ask if I did it right. I think I did it right, but maybe I missed something. Let's see. But yeah. I think we're at the home stretch here. We have to do... If this is fine, then we're done with the let function. Well, I'll probably ask him if there's any other cases for that, but I think we're fine. Oh yeah, don't do Python for crafting interpreters. I mean, even in the book, the crafting interpreters book, the main criticism of Java, like even in the book themselves, they said that Java is too slow to do this. So that's why the second part's about C. Like in the book, I'm pretty sure I remember in the book they said that, so... Python will be even way slower, so... Have you felt any burnout with C++? Not really. It's still pretty fun to me. I'd say in I think January or February. No, January. In January, I started doing some Python backend stuff, but I got burnt out with that just because of the fact that I didn't know what I was even doing. I was vibe coding for the most part, so it felt unaccomplishing and it just felt boring. It felt nice at first, but then after a while, I got old, and as I added more stuff, it got way more complex and annoying for me to actually understand what's going on. So I thought I'll go for something I can actually think more on and actually have fun with. And I was right to pivot to C++. Gotta go, Lego. I'll see you later, man. Appreciate you for joining the stream. Python backend is so annoying. Yeah, it wasn't that fun. It was pretty annoying. It does have a lot of things you can't do in it though, since there's just so many packages that people make. So many different libraries. In 24 bytes? Yeah, probably. I know it's definitely way more than the C++. Low can feel restrictive. Yeah, I can see that. I can see that. I think Cloud's probably done by now. You have one bug. Where's the bug? When you see a comma, you actually need to consume it, not just check. Oh yeah, you're right, you're right. Because a comma is needed no matter what, so we need to consume it, not just check for it, yeah. You're absolutely right. Wait, so... yeah. After arc. Or wait, okay, wait, what? Oh, he means consume it like that. Oh, okay, I got confused with the consume function. With the consume function, yeah, this doesn't convert to... This shouldn't convert to a bool, I believe, so... Yeah, we can't do that. Let me reverse that. But in here we want advance. We need to actually consume it. I forgot about that part. But yeah. Well, wait, hold on. We're not... Okay, so we're checking if it's not here. But okay, yeah. If it is here, then yeah, we need it in here. Wait. No. I'm thinking of it wrong. Wait. My brain is not working right now. It should probably be... outside? Outside before the... outside of the comma. If... okay. My brain was not working there for a second. I think one thing I find interesting would be Gleam-based interpreter. What's that about? Gleam-based. What other issues are there? One edge case worth handling. What if left parentheses is immediately followed by right parentheses? Don't I have that checked? Right? While not check right parentheses, while it's not a right parentheses, so if it is a right parentheses, it should just consume, right? It should just consume this, right? Wait, doesn't have 4 keywords, so all iterations done using recursion. Dang. Is that really like a necessary thing though, to have no for loops? Because I feel like those are very useful to do iteration based. What's up, Emac? Why ask Claude if your code is right when you can write tests to see if it works? My opinion, first step should be to run to see if it works. Only ask Claude for a review after that. Yeah, you're right. I'm not good at that yet. I don't know how to do that yet. Write tests. I'm not good at writing tests, but that's something I need to work on. Even for my emulator, I usually just ask Claude if my code is right or not, rather than debugging myself, which is something I need to work on. I will eventually work on that. But I need to learn how to write tests first. Oh, that's also a good check. Yeah, that's a pretty good check too, so checking if it's not at the end. How do you get your taskbar like that? What do you mean by taskbar like that? Yeah, that's something I don't know how to make tests. That's something I should work on, to be honest. I probably will do that, maybe for the back end when we move on to the next part. I'll probably write specific tests. For my emulator, all I did was just test using random bit strings that I had generated. But I will definitely take a day, sit down, and learn how to do tests and proper debugging. They're the full name instead of icons. It just came like this for me. Whenever we like open a thing, it just has the name. I don't think I have to change anything for that. What did he mean though? I think it's fine. Yeah, everything's fine. Here. Yeah, they just came like that. Yeah, you're right about that. I did actually find Emac. I actually found that Claude did get stuff wrong in the emulator. Like in some off cases for a certain instruction, it might have gotten either the casting wrong or it might have gotten the actual specs of the instruction wrong, which I always double checked with the actual documentation when I was writing the risc-v emulator. But I did catch it make mistakes a lot. So I do understand where you're coming from. So you're probably right. I do need to improve that. And I will. I promise. Yeah, risc-v does have an official test. I just haven't got it set up for that. I guess I was just too lazy to set it up, but yeah. I will. They have like a little toolchain for setting up random tests for risc-v. For the most part, it should be right. It just gets stuff wrong if it's very specific stuff, like specifications and so on. Okay, are we officially done with this? Also, I probably should get better running tests because, like, I haven't tested this once at all. So I don't even know if I'm even, like... Yeah, it's a problem if I have a bunch of problems when I actually test it out. So it's probably good to learn how to test bit by bit instead of writing a huge chunk. Done. I think we covered everything in the let function now, so that should be good. We have the specific functions. Is Google Test good? I actually haven't heard of that before. This is a good case for practicing testing and or test-driven development, as you quite well know the spec and what the expected behavior should be given some input. Yeah, that is true. That is true. Yeah, I have a very small Discord server. One question I have, are using a lot of heap allocated memory, statement system. Do you mean like all the vast amount of unique pointers? To be honest, I wouldn't know the actual entire reason for why. When I was reading about compilers, I saw two ways that people tend to do it, which is using shared pointers for each node. All nodes would be shared, or a unique pointer, so like each parent node owns their own child nodes for each statement. And that's the two ways I saw. I just said, all right, let's just do a unique pointer way, and let's just try it like that. But I wouldn't know the actual under the hood reasons for why. Is that a step why you use to share streaming YouTube? Does Discord just do that? What do you mean? Self-bot? I just put in the Discord server the link whenever I start streaming. I need to set up bots and all that stuff. I need to set up my Discord properly. Does unique pointer use an arena? That was just enter new. I'm not actually sure. I thought it was just enter new and delete. I thought shared pointer was like, well, I don't know what the term arena allocation is, but I know shared pointer is like an atomic increment and decrement instruction for each pointer that's being shared. So whenever you stop using it, it deletes it. So decrements by 1, and once the count hits 0, then the pointer is deleted. But for unique pointer, it's just one singular one, just owning it, so I thought I'd just delete it as soon as you're not using it. I go for now. Unfortunately, I have to go learn C++. Alright, see you later, Jennifer. Appreciate you for joining the stream. Man, I have a lot to learn about C++ language features. I really do have a lot to learn here. Okay, so we finished, okay, all of these. All right, looks like that's good. To be honest, I don't know what because after I finish the parser, I might not be streaming for a while, or I might do, I don't know if I should do like random streams where I just do like DSA or some random stuff, or studying C++. I don't know if that's interesting, because between each compiler phase, I'm probably going to take a couple of days, unless I do a different type of stream. So I'm not sure about that. Alright, so now we have to do error handling. Okay. Alright, so this, okay, so we make a class for parse error. Checks the required token is present. Yeah, we already have the consume there. That's specifically for the error handling there. If it doesn't consume a right token. Synchronize. We haven't wrote that function yet, but what it does is when a parse error is caught at the top level, token cursor. Okay. Okay, so it's just discarding tokens. Okay. So just moving back until we find something valid. So starting keyword, semicolon. Plans the parser to safely resume analyzing the rest of the file, or report multiple errors in a single compilation run. Random streams to cover other content would be fun. I would particularly enjoy language learning, but that's just me. DSA would be nice, and so would learning tools. Yeah, I might honestly run a pretty decent run, to be honest, with the channel, so might as well keep it going. Do random streams and such. Yeah, it'd probably just be like DSA or C++ language knowledge, expanding that knowledge. Or maybe even learning compilers on the stream. I don't know, we'll see. But that seems like a good idea. Okay, let's try and do that. Should I set up in here, parser.h? Yeah, I guess so. Let's just do that. So we'll set like a class and maybe call it like parse error. So we'll say like that. How do we handle this though? Okay, so let's probably set up like the synchronize function. What should it be? Should it return anything or should it not? I mean, I guess it's just gonna... I guess just void, right? So we can say void synchronize. Set the function here. I love DSA, but I believe you should take a couple breaks in between. Stay 7 afterwards, a full week. Yeah, maybe like a 1-day break. I just don't feel burnt out at all, so I feel like I could keep going. Alright, this is where I tend to not know how to go forward. Errors are not really my thing, because it goes hand in hand with debugging. I haven't looked into all that stuff, so not really good at errors, so I might ask Claude how to like work on the errors itself, potentially. Just to get an idea of how to actually do it, because then I can understand for future error checking. How do you suggest I handle errors? We already have synchronize function should. I'll just give him my Obsidian note for the function synchronize. And yo, what's up, Ghost? Welcome back. We finished the parser, but error handling is where we're at right now. And I don't know how to move forward with error handling, so not necessarily outsourcing it, but I'm just seeing how to go forward. Yeah. We should probably take token by const ref, since it takes us to string, or move it in. Which part? Which part? Like all these tokens that we're making here. You also want to move the token to the parser constructor unless you want to copy. Possibly. Do you not just inherit from std error family? I forgot which class though. Yeah, you're probably right. I should probably take these all by reference. I will do that probably soon. Later. I have to do that for each one, so std error family. Oh, you mean like this? Inherit from public std runtime error. I don't know what this is all about, but I guess we can learn this. We can learn how this is used. This is my first time seeing this, like, whole error thing. So parse error should be a separate class. The method synchronizes a parser operation, so it belongs inside the parser class itself. Parse error should just be a lightweight exception through type B throw and catch. Okay. Okay, that makes sense. So we'll call it like we'll put it in the helpers, I guess. Bear with me here as I learn what this all is. Okay, I don't want to see the part. I don't want to see synchronized logic. I want to do that myself. I want to do the synchronized logic myself, but I just want to see what this is all about. Parser. So it should be inheriting from std runtime error. I believe we did use that earlier too. Here from std exception. What's the difference between? Okay, let's go and implement synchronize using whatever we have here and see. Sounds pretty fun. Let's add it up here with all the other helpers. Void synchronize. Okay. Let's see. When a parser is caught at the top level, the token cursor is still pointing at the bad syntax. If the parser tried to continue immediately, it would infinitely crash. Synchronize discards tokens until it finds a clear synchronization point, like a semicolon or a starting keyword like if, int, while. This aligns the parser to safely resume analyzing the rest of the file to report multiple errors in a single compilation run. Okay. I mean, let's just map out an error, I guess, like an example of an error. And I guess let's say like if condition, but let's say we forgot to, okay, let me do the comments. Let's say we forgot to close it, and then we just do like that. Right? So does this mean that when we go through if condition and then we reach here, we expected where is the if statement? Here. We expected the right parentheses, right? So I should throw an error for that. So what I'm kind of getting at from this is that it discards these tokens until it reaches a keyword. Starting a keyword like if, int, while. So once it reaches back here, which is a good starting point to go back to. I mean, that's where we would use the previous function we have here, the previous function that we instantiated before. That would give us the current -1 token value. Where did I do it? Oh yeah, right here. Tokens of the current token -1. So let's say we reach yeah, I plan on doing that soon. I thought I'd be finished by today's stream, but actually it feels like we have a lot to do still. I don't know. Maybe I guess like after we write this, I'll probably end the stream. We'll probably finish up tomorrow and then probably do some other stuff like C++ or DSA or whatever. Std runtime here is derived from the std exception class. Interesting, interesting. Okay, so once we hit the right parentheses, we're consuming that token. Right. Let's consume it. Yeah, consume advances. Okay. It says only if the type is valid, but in this case, it's not there, so we haven't advanced it. Yeah, I appreciate it, Wellsard. Yeah, I'm still trying to do the best I can here. Really appreciate all the support for this. Yeah, that's pretty much what it is. It just moves backwards. It just discards the tokens that are going to cause the compiler to crash. These notes I wrote were just like a culmination of crafting interpreters, me talking with AI about things, and just any random YouTube video I could find on any stuff. So, yeah. I may not have fully understood everything I wrote, but as we went through it, I started understanding more and more as we kept going. So, okay, so do we need to advance? I'm trying to learn from you for my own project, so if you have any resources on compilers, it'd be greatly appreciated. Yeah, crafting interpreters is one, and that should be... Go to this one, this GitHub right here, System Programming Roadmap, and they do have on compilers like a bunch of different resources, different college assignment, lectures, slides, projects, stuff like that, and a couple of different books, and just even one like Make a Language in Rust, and all these other resources, LLVM. So yeah, I'm probably gonna go through one of these for the backend part because crafting interpreters doesn't cover that well for compiler backends. This is all I know of so far for like compiler stuff that's out there, but there might be more stuff. All right, so should we advance or not? Because we have the condition. I mean, I guess there's no reason to advance here, right? We don't want to really consume it, right? Or do we? If it's in the if statement. Right parentheses, expected after condition. Okay, we're advancing this token if that's the case. If not, we're returning that, but we probably... Maybe not. Maybe we just don't advance there. While is at end. So while we're as long as we're not at the end, we want to keep going with the previous one. So we want to call previous. So what exactly do we need to check? We need to, okay, so we're gonna move back condition parentheses. So I guess we just need to check the types, right? So maybe we'll probably have a switch case statement here, maybe? Like checking the type. The type that we're on. How do we check that type? switch previous dot type. Previous dot type maybe. Well, wait. Previous is gonna return a token, so we don't want that. We want to just check. So maybe I'm thinking of it wrong. Discards tokens until it finds a clear synchronization point. Maybe peak. So maybe like if we say peak, put this around it. Peak dot type. If our current value that we're on maybe I was thinking of it wrong. I thought we were going behind, but no, we're moving forward. We're moving forward. Okay, so we do probably want to advance before then to go on to the next token. I was thinking of it wrong. So switch peak dot type. Okay, so we're checking that type. And it said there are a couple cases. A semicolon, a starting keyword like if, int, or while. So any keywords, I guess. So I guess just take a case of the keywords. I think I can just grab it from. I remember I had a keyword map. I think it was in Lexer, I think. Not all those, but these ones. Int float. If a void, char, if else, while, for. Maybe return. Print. Guess these. Well, let me copy this properly. For each of these cases. But we don't want to return anything, so I'll just take that out from each. Yeah, I deleted too much. We'll take off each one here. So for each of these keywords that are valid, I guess we want to go through. What's up, Rhizome? Yeah, I'm an Obsidian user. I have like a whole repo on it for notes I take. My headphone battery's low. Let me just put that in. Alright. Hopefully the music doesn't change, because if I'm not gonna be able to hear it if it changes to a random YouTube video. So hopefully it's good, because I can't hear things anymore. Okay. And so for any keyword that we have. Yeah, I am the guy making a risc-v emulator, but that's finished for now. And we're doing the compiler now for that. Okay. But also a comma too. Also a comma too, right? So we'll probably say comma 2. Case type. It's so weird hearing myself without the headphones on. Feels so empty. Okay, comma, int, float. Oh, okay, that's up there. So for these cases, these are good points. I mean, if that's the case, we just probably return out of this function, right? There's no need for the function to keep going. probably return out. And probably advancing forward. We need a default case though, but after we get out, we advance forward so we can continue on with our parsing. All like the crashing stuff is gone there. We need a default case. So if it doesn't hit any of these, it's just gonna be any other case. Which in that case, we... I put it out of the case accidentally. Should be here. I mean, I guess we just break out of the switch statement probably, right? So breaking out of the switch statement, and then we'll re-enter the while loop. Or we'll keep going in the while loop, not re-enter. We're already in it, so probably a break. So then this will take us out of the switch statement. The while loop will advance forward by 1. We will continue forward with that. Can I be the one that teaches you Rust? That's if I learn Rust. That's if I learn Rust, but... yeah, if I do learn Rust, then that's all you can teach me. I think this is it, right? How close was I? I know Claude gave me a... oh, not far off, actually. Oh, I missed this. What is that for? Previous.type semicolon return. Wait, so the semicolon isn't in the peak type? Why not though? Wait, why not though? Let's say we have the condition, right? I don't know, they say something here. We continue advancing and we might end up hitting a semicolon somewhere. So that's a possibility, right? But the previous one. So I guess he's saying, if we advance forward and our previous value was a semicolon, I guess. Let me ask him. Why not put the semicolon case in the switch case first? Just explain me. Previous speak first, when you call advance to the top of synchronize, you move past the bad token. Yeah, we're moving past the bad token, but who's to say if the one past the bad token would be a semicolon or not? Or not a comma, sorry, semicolon. I meant semicolon. That's what I had in here. I wrote comma though, but yeah. Semicolon's still ahead of us. We haven't finished crossing the boundary yet. Because seeing int or while ahead means the next thing is definitely a new statement. Oh, okay. We're stopping this function. We're getting out of this function only if it's a starting point. So then we're passing it off as a statement. Okay. I see, okay. I thought of it wrong. Okay. But our semicolon, that's where the previous function will come in. We'll check that. So I understand. Yeah, we were close. We were close. So let's take out semicolon. Not bad. We were actually like maybe 90% accuracy there. 85%. So if I want that before this check, so if previous.type, I believe he said, or no, it should be previous function type equals token type semicolon. If that's the case, then it's fine. We'll just return, I believe. Okay. Alright, not bad. Alright, so that's the synchronized function we have done. I guess we need to set up parser. How did he set up the parse error class? The class itself. I need to see how he did this. So it's parse error. Okay, I need to ask him, why are we inheriting from std runtime error for error handling? What is the reason for that? So I can understand. What is the reason for inheriting from std runtime error? Is that a common practice? How can something like that. Let's see. It gives you the what method for free. And what is that? Std runtime error stores a message string you pass in the constructor and exposes it through what? Okay. That's why you can write e.what in your cache block and get the error message back out. Errors are weird, bro. But I guess I understand. Makes sense. As a hierarchy, std runtime error, your parse error, std logic error, okay. By inheriting from std runtime error, your parse error can be caught by any of these. Const parse error E catches only parse errors. Any runtime errors catches everything. Okay. Errors are weird, but it's something I need. It's probably very necessary for me to learn, so I don't mind. Welcome back, Jennifer. Yeah, you're still number 1. Let's see the list. Jennifer is number 1 by 50. Swan's number 2. Ghost is number 3. Interesting. Hopefully, Learn CPP teaches me more about this stuff to actually understand the full nuances of everything, but I haven't gone there yet. Okay. So I'll just probably say what he said, so. Parse error, const string message. I'll probably just copy that. So that's the constructor that we have for that. And the constructor should be public, so yeah. What do you think about Zig? Might be interested in learning that in the future. Why do you keep every combo with Claude? I just keep them if I might use them. This is for this is for my cybersecurity class. I was just writing notes for like every module. I was having it generate me notes for every module so I can go through, and I ended up getting a 91% on the exam, so I guess it worked. So yeah, I just haven't deleted it. I don't need it, so I'll probably delete it. and computer architecture, a couple of other stuff. I don't know, DevOps class. It's funny that we covered testing and DevOps, but we didn't actually do code for testing, so I don't know how to actually test it. So, yeah. They just cover the concept. They never taught us how to create our tests or write tests. That's the problem with classes like that. Appreciate it, Swan. Yeah, I was lucky to get a 91 there. Maybe if the DevOps class actually taught me how to do tests, like in code, I might be able to do them. But I guess we have to learn on our own. Yeah, what is Pythonista? I never heard of that. So, is that it for errors, or like, is that literally all that's in the class, or like, what? In the class, or what? Claude, you're gonna have to run me through this. I don't understand the errors that well. Okay, that's all you need? Okay. So to throw the parse error, throw parse error, and then expect it after if. Okay. Well, we do have the consume for that though, right? Like this stuff. Catch const parse error. Reference E error handle dot error take. Rust users are Rust stations. That's interesting. Now Lexer is done. Lexer was much simpler to do. The Lexer, I think I maybe asked Claude about a grand total of maybe 2 or 3 times, but for the parsing, I've asked it maybe 7 times, which is mainly for stuff I got confused on. I think most of my messages are from the error handling part, this part that I'm on right now, since I don't understand it. Consume already handles specific expected, so in practice, consume fails, throws parse error, parse code, catches parse error specifically. Okay. I low-key want to just test the parser, not gonna lie. Okay. And I guess so. I guess I do want it to prompt it up. For this part, the error stuff is just like, I don't know. I don't understand it, so I can't make my own decisions for this without understanding it, so I'm kind of delegating it to Claude here. To be honest, I don't mind if some parts are written by the AI. If I can do most of it myself, that's good enough for me, to be honest. Okay, so that's for that, right? So we do need to write our parse code specific function. This is for parsing the entire program. So let's get that down here. Yeah, I will test it after this. After this, setting it up, I'll see if I can run it. Okay, so what? Let me grab that. Let me grab this here to implement. So this is like this. This is like this. I have a feeling we're gonna get some errors when I run it the first time. I don't know. I just have that feeling. So I guess this is where the parsing errors would happen, right? We need like a try catch, I guess. I remember he said try catch as we're parsing through if we get something wrong. So let's make a vector here. Let's make a unique pointer for statements. I'm gonna make this a statement 1 because this will be passed on to any other functions that use the statements 1. Unique pointer of statement, and we'll call it a statement because that's what we said earlier in other parts of it. And we're gonna go for every single token in the file. So we want to say, as long as we don't reach the end. As long as we're not at the end, we want to say, what is it? Is it not try catch or? Well, okay, so try is just when it's regular, when we're just going regular, right? So try, we want to add our statements that we have. So statements pushback, and it'll be calling a statement, so it can be handled there for whatever statements we have. And then statements will further on call expressions, and then so on and so forth until we get it. And we probably want to do catch, and this is where this part comes in, right? So catch, like here, I guess. Const parse error and e. And I assume that's when we hit this error. This is where our synchronized function will take over and try to restore back to a stable place. I think. Hopefully, I'm right. Then once we're done with that, we exit the while loop, and then we return statements, the vector, so we can actually see, possibly. What next? I think that's right? Let me see. Does he think it's good? It's always swelling there. Oh, okay, I forgot like stuff inside. Oh, like this part? Okay, I don't understand this line. What is this line exactly do? Well, okay, wait, no, that should be our, I think he took it from our main error.h here, the error line, which would give us our line and the message of the error. That's where he took it from. Yeah. Then what is, okay, I didn't understand fully what the what does. What does the what do? He said that's a good way of having it because it's from the std runtime error. what does the what method do? Train and get the error message back out. Okay, so we're getting the error message back out, I believe. Yeah, it's a mix of recursive descent and prod parsing. It's just something I decided I would do. So for statements which are more top down, you just go line by line and keep moving on. That's for recursive descent parsing. But for expressions that have precedence, rules, and all the specific stuff of that, we do prat parsing. We pass it off to the prat parser to handle the precedence and which should go from left to right associativity, right to left associativity, and so on, depending on what the expression is. I'll probably make a video after. I'll probably make like a devlog video or something running through everything. And I'll probably refine some stuff, probably add some more comments around the code to explain stuff better. And then probably push it out to GitHub. Okay, where was I? Yeah, okay. Any reason you chose that over precedence climbing? Not really. I just kept getting recommended videos about prat parsing, so I decided to look into it, and I thought it was pretty genius, to be honest. I thought it was a pretty unique implementation. So I was like, yeah, let's probably do that for our compiler. So I just went on a deep dive about it, wrote notes about that, and wrote notes about recursive descent. Kind of mapped out how I should do that part. Okay, yeah, this thing. So this will call... Well, error handler, where's that at? Where am I at? Okay, here. Well, I put error handling here. Maybe don't want that. Probably don't want that. Your parser needs error handling as a member, passed through to the constructor, same way as the scanner does. Yeah. So we'll probably get that in. I'm back after testing my monitor on tons of games. Welcome back, Bastion. We've hit kind of a roadblock here. Error handling. But yeah, we're almost done with this. Once error handling is done, I think parsing is done. But I need to check if there's one more thing. And maybe we can test it on this stream. Hopefully. And I hope it works. Or else we'll probably need another stream for debugging stuff. Okay, so we do want to pass it in. Into our parser class. How long do you usually stream? Usually like 2 to 3 hours. It used to be like 1 hour, but now I'm starting to get like more traction so I can go longer. I have the motivation to code more. But back then it was usually 1.5 hour, 1 hour. Now it's like 2 to 3 hours. Yeah. So we want it to be in here, I assume, and pass it through the constructor as well. So we want to possibly, just like how we did here, grab that and then, okay, error, okay, yeah. inside the constructor here. Okay, and then that should work for the what's wrong here? Oh, I didn't call it error handle, I called it just error. Maybe it's better to distinguish, to be honest. It might be better because the error is the function name. Well, it's already distinguished well by the underscore. It's fine. We can just keep it error. That's not a problem. And why does this not work? Did we not prepare for that? We can't copy error message. Okay, so declare line 94. Oh, that's like the actual thing. Okay, wait. What's going on there? What's going on there? I'm gonna give him like literally everything. So is that accessing what is accessible? Okay. Oh, I missed that? I missed that. Yeah, I have to for this part. I don't understand errors that well. So that's unfortunate. I'm gonna have to take a day or two to maybe understand how to properly do error handling stuff. It's unfortunate. I don't want to give it to Club, but I don't understand how to do it myself here for this part. But I can gladly say for the rest of this I did myself. For the most part. Like 90%. Okay, now it works? Okay, now it works. But to actually test it though, we had a run function within here. We probably want to move this though, because we don't want this to be in Lexer now. We want it to be a run function for the entirety of everything. So we probably want to add that. We probably want to add that in here and say, all right. So what exactly do we need to change that for? Scanner source, error handling. So I guess we just need to pass that. Did I put run function in here itself? No, I didn't, so. Should the main function just inherit, like, assert.h? And we likely want to do the parser part now, but we want to change this. I don't want it to just bring out tokens now. Ooh, not that. So we probably need to do the same thing, just very similar. So for now, h, and we want to just declare say parser guess we'll just call it a parser. And that should take in just the tokens and error handling part. So tokens and error handling. So okay. Okay, so that's good. Initializing that. We probably want to say parse program. So we want to, where is it? Parser.h. We probably want to grab that set vector to parse the code, parse all the code. So we'll say set vector unique pointer parse code to call that function. But it should be for the parser. So parser.parse code, just like here, scanner.scan tokens, parser.parse code. We need to give it a name, yeah, that's why. Code, I guess. Parse code. And I think that's it. Well, we don't want this anymore. Okay. All right. Okay, but we still can't test the. What exactly are we gonna test? No, I probably might just commit this for now. But just make sure everything's good. Probably commit this for now and then see how to test it. Yeah, I don't know how to do the testing part. I don't know exactly. So I was gonna give the link of the GitHub to Claude to actually tell us how to test this. For the lecture, we just tested the file with the code we had in here earlier. For each token, we just went through the for loop for each character, and then returned the tokens as we did. So in this case, yeah, that's the only way I know how to do it right now. So yeah, I'll probably just commit it real quick. I think committing is safe on stream, so that's fine. I'll just commit it on stream here. I just need to grab that. Everything's saved, right? Yeah, let me just do a quick save on everything. Let's see. Okay, so that should be good. And I guess now it likely got that. Yeah, does master branch started log on move that to main. When I was setting up originally I had this like just the emulator. I remade the whole build, and I guess this is what happened when I was remaking. I learned like the CMake stuff and learned how to make the build, and I don't know, it just became master. I don't know if that's a problem or not, but yeah. It used to be main though, I thought. Does Claude just take the code? Allow the code to be taken? Oh, there's a funny joke about it? That's interesting. Because, yeah, this used to be just a random Visual Studio build with all those VXC, I don't know what it's called, VCX proj files or something. But then I was like, okay, let me make a proper CMake build and let's make everything proper and structure the project properly. Want to test it all. For the next phase of the compiler, I'm going to learn how to do tests and error properly so we don't get stuck at these parts. For the next part is probably the IR or the code generator, so we'll probably have to learn how to write tests for after every single function we do to test it properly. I want to know how to test this. It's usually just testing with the test file. This was for the lecture. I just made a random test file.txt to test everything. But this probably won't be the same. We'll probably need to add some stuff, but yeah. Oh, you can fetch it from GitHub. That's interesting. I didn't know Cloud could do that. Yeah, testing frameworks, I don't know what's there. Oh, did not see? I did write it into run though. Is he not able to see it since I just committed it or something, or? And what is this? Write an AST printer so you can actually see what the tree looks like. I have to do this? Oh my god. Yeah, I mean, I understand because the tokens were just like the flat tokens. But now we need an actual tree to be built. That's interesting. I might just low-key copy this. This looks very redundant to type out every time. And run. Oh, there's surely a better tool to visualize a tree. Probably is, but I will follow Claude's lead for now. ASTprinter.h. That's interesting. Okay, let's just do that. Okay. I guess. It feels weird just doing this, but it's fine. And how is it? Okay, so it's gonna have to. There.h. But it's also gonna need the AST.h as well. What's up, Lucy? I'm doing good. How are you? Well, it should allow that, right? Why is it allowing for these but not these? What's wrong with that? What's wrong with it? Did I mess up something earlier? Wait, so function call and identifier. Let me look at this. Let me look at the differences. Identifier, call node, virtual int. Wait. So for every expression one, it looks like we. No, for this one it's fine. What is then branch? Didn't I just call it branch? Why is Claude making stuff up? And statement. Block statement. Wait, let me look at the block statement. Block statement. Oh, I just wrote body, I didn't write statement. Why is Claude like making stuff up? I see. It got the naming wrong. Okay, that's why. Well, okay, that's fine. Literal node for the visit. What did I call it? Visit literal node. I did call it that. Visit literal node. Binary op node. Visit literal node. Identifier node. I mean, that's correct, right? So why is that? These two are wrong, but something's not quite. Oh, it gave the wrong data type. And then that's the token, yeah. Dude, that's like 5 mistakes or 6 mistakes in this file already, dude. That Claude gave. I'm not sure. Doesn't matter. Okay. Alright, looks like it's fine now. That was a lot of errors in there, but okay. What else? In our run function, okay, we already did that part up there. The run function. Well, we don't have an AST printer. Where did it get AST printer from? Dude, Claude is making random stuff up, bro. We don't have the AST printer. What is our thing called? This, oh no, we do have it. Okay, never mind. It wasn't making up for that, but for the other stuff it was. The AST printer, yeah, sorry about that, Claude. But for the other stuff you messed up. Yeah, we need to, let's do that. RST. Where did we do that? Oh, he changed the name. Okay, dude, why are you changing the name? Okay, you're right. It's probably a better name, but like, okay, no, I'm keeping my name. I'm keeping my name. Dude, literally, like Claude, he changed the name of at least like 4 or 5 things here. I don't know why. It's like, it's so weird. And he literally changed the name that I put here to a different name. And he doesn't even say that he changed it, he just does it. I'm probably gonna end the stream after this testing. If this test comes out fine. If not, I'm probably gonna test tomorrow. If this test is terrible. We'll see if this test is fine. If not, we'll probably test it tomorrow on stream. Tomorrow we might do like the testing and probably just do some DSA, C++ knowledge stuff. Learn some stuff. Because I need some time to learn whatever I need to do for the next steps. Okay. And how should I test? Same commands as before. Vendor some testing frameworks. Yeah, probably. I have to look into that. I don't know what is there, so I have to look into it. Okay. Let's hope. Let's hope. Let's hope it's good. I'll just I mean, I should probably compile this all right together probably first. What is going on there? All right, yeah, we'll see. But let's just see if the command might have. Let's just see if we can actually get in the command and probably test what it is. It likely won't do good on the first iteration anyways. What? What did I do? It should be this, right? / compiler.exe, right? Claude knows a lot, probably. Yeah, about like, what do you mean, like Claude knows a lot about which frameworks to use? Alright, not gonna lie, these past 30 minutes of this stuff has been so terrible. This is not working, but working on some advanced physics via Claude. It works pretty good. Nice, nice. Advanced physics. Oh, okay. Alright. Am I doing something wrong? saying compiler.exe. I mean, shouldn't it be compiler.exe? It is compiler.exe in here. It removed the dot from earlier. Okay, let's just test it and get back. I don't know. It was working before. That exact same command was working when I was testing the Elixir. I used this command to test Elixir, but now it doesn't work for the parser. Wow, that's weird. Would it even work in Git Bash? Let's see. Can we even test it in like that? Let's see. Okay, yeah, no, it's not. It doesn't even know it's a directory at all. It doesn't even know it's a directory. Try to Git Bash. Alright, what is this stuff now? We're completely deviating from what I want to do, but okay. Alright, CD for that, and we can't... Well, you gave me the one for Git Bash, so okay. /. Find the name. What does that even do? It didn't even give me anything back. If we can't get this for the next 5 minutes, I might just end stream and figure out what's going on, and then do the test tomorrow or whatever, with a new testing framework or whatever is there. Didn't open anything. Cloud's running me in circles here. Oh, is it because it didn't build properly at all? Oh, because we had some errors. We had some errors though. Okay, that's why. That might be why. Oh, we have a lot of errors. Holy shit. Well, I guess that's kind of what I get for building out the whole thing without testing. Well, that's a good lesson learned. I mean, that's what we always hear, to build out chunk by chunk and test, but I completely disregarded that and just built out the whole thing without testing it once, so yeah. It's probably a thing for tomorrow. It's really late. It's 1:36 a.m., so yeah, a lot of people complain about C++ move semantics, yeah. But yeah, I probably might end the stream today. It was a pretty productive stream for the most part. We did get the nud function and the led function for the parsing, so we finished all of that. That was fun. Error handling was not fun, and this was not fun. But yeah, overall a pretty productive stream. We had a lot of people join today as well. I appreciate all the support. We had Jennifer, Swan, Ghost, Bastion, Lego, AJ Brady, Rism, I don't know how to pronounce it, but yeah, Emac, Wellzard, EXO, a bunch of other people. I appreciate you all. And yeah, I guess we're gonna end the stream tonight. Have a good night, everyone.